আচ্ছা, so যেটা লাস্ট ক্লাসে বলতেছিলাম, if you can remember, patterns in ionization energy. দেখো, if I ask you এই যে গ্রুপগুলা, say a metal, group 1 metal, ওরা দেখো melting and boiling point একটা প্যাটার্ন ফলো করে না? If you go down the group, boiling point decreases, melting point decreases or increases. What do you think? Melting point decreases down the group of group 1, because the cations are becoming bigger and bigger. That's why the electrostatic force of attraction between positively charged cations and negatively charged C of delocalized electrons will decrease. The electrostatic force of attraction will be weaker for group 1 and group 2 metals. Thereby, boiling and melting point will decrease as you go down the group. But for halogens, দেখো, halogens their মধ্যে যে attraction, that is intermolecular force of attraction. Okay, and we know for intermolecular force of attraction, greater the MR or greater the number of electrons present in the molecules, there will be greater intermolecular forces of attraction. So as you go down the group, boiling and melting point increases for group 7. ঠিক আছে? So আমি যেটা বলতে চাইতেছি, we have already explained many patterns followed by different groups and periods. Here we are introducing another pattern which is based on ionization energy, and we are saying they are following a pattern across a period. So for period 3, the elements will follow a pattern in ionization energy. For period 4 or period 2, they will follow a pattern. In this case, we will discuss only the very initial elements, say hydrogen to sodium, and how the pattern is changing, that we will discuss. And say, for example, if they give you this graph, and they ask you the change in pattern of the ionization energy or trend in pattern in ionization energy from hydrogen to sodium, then they will give you almost 6 marks for this. 6 marks they will give, and they will ask you to explain. I mean, last class when you will explain, you will try to explain ionization energy in terms of these 3: nuclear charge, radius, and shielding. Did you read this? I asked you to read these points. Did you read? No.
I couldn't read yesterday.
Acha. ঠিক আছে. আচ্ছা, so যেটা বলছিলাম যে if you describe the patterns one by one, that hydrogen to helium, then helium to lithium, then lithium to beryllium, then beryllium to boron, then boron to carbon, 1 to 1. If you want to discuss, you need 1, 2, 3, 4, 5, 6, almost 10 to 11 paragraphs, right? So that's how you cannot go. So what you will discuss, the major part or major changes in this graph. Major changes are what? Number 1, hydrogen to helium, why arise? Okay, this is number 1. Number 2, helium to lithium, why a big drop? So this should be second year. আচ্ছা, আমি এইভাবে না করে এভাবে করি বেটার। আমি যেটা বলতেছি, আমরা এইটা এক্সপ্লেইন করব নাম্বার 1, এইটা এক্সপ্লেইন করব নাম্বার 2, ঠিক আছে? এরপর আমরা এই পুরোটা এক্সপ্লেইন করব নাম্বার 3, ঠিক আছে? একটা there is a gradual rise from lithium to neon's first ionization energy, except for 2 discrepancy, which is beryllium to boron and nitrogen to oxygen, that we'll discuss. And neon to sodium has the same pattern as helium to lithium, because helium to lithium it's a big drop because of the drop increase of one shell. Neon to sodium has a big drop because of increase in one shell. Okay? So দেখো আমাদের মোটামুটি এই কয়টা major part আছে, including these 2 discrepancies that we'll discuss. Fortunately, they will not ask the whole thing all together in a question, and they are not capable of giving 6 to 8 marks to you. Okay? They should give 6 to 8 marks if they give the whole thing together. So maybe they will split the thing. Sometimes you will find they are asking question like this: why there is a drop, even though lithium to neon there is a gradual rise, where there is a drop between beryllium to boron? That is one question, 3 months. Do you understand? That's how they give. They split the questions, or they will give this graph and they will ask why helium to lithium there is a big jump, big drop. That they will ask, or why nitrogen to oxygen there is a small discrepancy. That they will ask, and they will give you 2 to 3 marks. That's how they ask you question. ঠিক আছে, but আমরা পুরোটা জিনিস একসাথে ডিসকাস করতেছি. So what split of questions they will ask, you will answer accordingly. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. ঠিক আছে, তাহলে আমরা যাই. Okay. First thing, আমি পরে পরে এক্সপ্লেইন করি তাহলে বেটার বুঝতে পারবো ইজিলি. এটা দেখো. Number 1, there is a general increase in first generation energy across a period. There is a general trending increase. Why? Because nuclear charge increases across a period. From lithium to neon, দেখো, nuclear charge is increasing. Agreed? Agreed. Nuclear charge is increasing.
Yes, sir.
From
Yes,
lithium
sir.
to neon. Right.
Yes, sir.
And the distance between the nucleus and outer electron remains reasonably constant. So across a period, see, all these electrons are removed from which subshell? 2p and 2s, my second quantum shell, right or wrong? Second period means second quantum shell. All the electrons from lithium to neon are removed from second quantum shell. That's why there is a general increase in first generation energy across one period. So the distance between nucleus and outer electrons remains reasonably constant, almost একই রকম. And number 3 is the shielding by inner shells remain reasonably constant. Reasonably constant, why? Because the electron is removed from the same quantum shell. So in the inner shell, you will get same number of electrons. So for lithium to neon, all these elements have 1s2 electron in the first quantum shell. From 1s2, they will get the repulsion force, or shielding will be done by these 1s2 electrons for all these lithium to neon. So nuclear charge increases. So this is the main factor. Distance between the nucleus and outer shell electron remains reasonably constant. Shielding remains reasonably constant because the electrons are removing from the second quantum shell. That's why there is a general trend in increasing of the first generation energy, because this is the main factor. This is the main factor here. Is it clear? Number 1 point.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay, so as I'm saying, you must touch this 3 points. Think properly and write accordingly. Nuclear charge is increasing from lithium to neon or across a period. Atomic radius, or this is at nothing but atomic radius, right? Distance between the nucleus and outer electron means atomic radius. Right?
Yes.
Right. So atomic radius remains reasonably constant, and the shielding remains reasonably constant because all these atoms present or elements present in period 2, or if you say in period 3, the same reason you will give. So all these electrons will get the same shielding from the inner shells, but because they have same number of inner shells. So number 1 is done. Fine. Number 2, there is a rapid increase in the ionization energy between the last element in one period, rapid drop, rapid decrease between the last element in one period and the first element in the next period. So we are explaining what? We are explaining these two. There is a rapid decrease of first generation energy between the last element of period 1 and the first element of period 2, and last element of period 2 and the first element of period 1. Do you understand? বুঝা যায়?
Yes, sir.
Rapid drop, big drop, dramatic decrease. Anything you can say. Why? Again, those 3 points will come. The distance between the nucleus and the outer electron increases. And this is the main cause. This is the main cause. Because তুমি দেখো helium হচ্ছে 2s2 আর lithium is 2s2, sorry. Why 2s2? Helium is 1s2 and lithium is 1s2, 2s1. You see, lithium's electron is removed from the second quantum shell, whereas helium's electron is removed from the first quantum shell. So that is a big difference. And so it will be much easier to remove the electron from the outer shell of lithium than in helium. Is it clear? It will be very easy to remove the electron from lithium because the outer electron is much away, is far away from the nucleus. If we compare with lithium, lithium's electron is very close. It is in the first quantum shell. So that is the main reason because of the for that dramatic decrease. Number one. Number two, the shielding by inner shells increases. So see, helium doesn't have any electron in the inner shell, whereas lithium, see this electron, outer shell electron which is removed, will get shielding from this 1s2, that is principal quantum shells electron. ঠিক আছে, লিথিয়ামে ইনার শেল আছে, হিলিয়ামে কোনো ইনার শেল নাই. So no shielding for helium, but for lithium, 1s2 electrons will give shielding to 2s1 electrons. Is it clear? Eta?
Yes,
Yes, sir.
না বুঝলে কোয়েশ্চেন করা লাগবে কিন্তু. আচ্ছা, these two factors outweigh the increased nuclear charge. দেখো হিলিয়ামের 2টা প্রোটন, লিথিয়ামের 3টা প্রোটন. Even though lithium's nuclear charge is higher than helium, but these two factors, the first two factors, will cancel out or outweigh the increased nuclear charge. Increased nuclear chargeর জন্য লিথিয়ামের আয়নাইজেশন এনার্জি বেশি হওয়ার কথা, বাট বাকি দুইটা ফ্যাক্টর এটাকে আউটওয়ে করে, এই কারণে lithium's first ionization energy is much less than helium. So that is the thing. You understand?
yes, sir.
So how will write? Even though lithium has one more proton than helium, or you can write even though nuclear charge of lithium is higher than helium, but the distance between the nucleus and the outer shell electron of lithium is more, so the ionization energy is more, and lithium will get shielding by 1s2 electrons. Okay? So these two factors outweigh the increased nuclear charge. So that is your answer for 3 marks. They will ask you for 3 marks. Why there is a big drop between helium and lithium, or neon to sodium? Why there is a big drop? So that's how we need to answer. Number 3, there is a slight decrease. Okay, beryllium to boron. এটা এবার আমরা ডিসক্রিপেন্সি গুলো এক্সপ্লেইন করি, জাস্ট ডিসক্রিপেন্সি গুলো. সো আমরা তো অলরেডি বলে ফেলছি why there is a big drop. এইটা কেন বিগ ড্রপ, এটা কেন বিগ ড্রপ, এটা এক্সপ্লেইন করছি. Why there is a gradual rise between hydrogen to helium and lithium to neon. Why there is a gradual rise. So আমাদের সব explanation we have done with 2 factors, তাই না? সো ওদের স্টাইলটা দেখো, স্টাইলটা ফলো করো, খুব সুন্দর স্টাইল. ফার্স্টে ওরা ইনক্রিজ গুলো কেন আর বিগ ড্রপ গুলো কেন, এই দুইটাকে এক্সপ্লেইন করে ফেলছে. সো ডান. এখন জাস্ট ওরা ডিসক্রিপেন্সি গুলোকে এক্সপ্লেইন করবে, and the whole graph will be explained. So beryllium to boron, why there is a small drop, and nitrogen to oxygen, why there is a small drop. Let me explain and then we will check what they said. Acha, first beryllium to boron, why there is a small drop. Let us start. ভালো করে খেয়াল করো, এটাও 3 মার্কসের জন্য they will ask. Beryllium, boron. Beryllium is 4, boron is 5. Beryllium is then 1s2, 2s2. Boron is 1s2, 2s2, 2p1. Right or wrong?
Right, sir.
Okay. So now, if you look at beryllium has 4 protons, whereas boron has 5. So the nuclear charge of boron should be more, right? And ionization energy should be more. So this is basically a factor which is contradictory to the drop, right? So even though boron has more protons than beryllium, but there are other factors. So nuclear charge, we have explained. Nuclear charge will be offset by other factors, offset by other two factors. Number 2, देखो, the electron of boron is removed from 2p subshell, whereas electron from beryllium is removing from 2s subshell, right? আচ্ছা, কাউকেই দেখতেছি না, তাহলে কি কার দিকে তাকায় কথা বলবো বলো তো? একজন তো থাকবে যার দিকে তাকায় একটু কথা বলবো। সামি, তুমিই থাকো, কি করবা? ভলান্টিয়ার। আচ্ছা, so 2s and 2p ঠিক আছে? So in 2p you see 2p is a bit higher energy level than 2s. Do you understand this? 2p is a bit higher energy level than 2s. Do you understand?
Yes, sir.
Yes, sir.
এই যে আমি যদি আবার if I go back, so সাবশেল গুলো যদি দেখো, এগুলো হচ্ছে এরকম হয়ে গেল, right? So increasing energy, you see, this is 2s and this is 2p. 2p is a bit higher energy state, higher energy level than 2s, right? Nazifa, ঠিক আছে? So এটার জন্য ইলেকট্রন রিমুভ করতে we need less energy. যত উপরের দিকে মানে ইলেকট্রন যত, ধরো এটা হচ্ছে ওদের নিউক্লিয়াস থেকে ইলেকট্রন যত হায়ার এনার্জি স্টেটে থাকবে, it will be easier to remove that electron. So that's what we say here. So 2p is a bit higher energy level than 2s. That's why removing 2p electron will be easier than 2s, right? So this is number 2. So the distance, or we can write 2p is higher energy level than 2s. So that's why it will be easier to remove the electron, number 2, right? And yeah, this 2p electron will get shielding from 1s2 to 2s2, both subshells. But this 2s2 will get shielding only from 1s2. Whereas boron will get shielding from 1s2 and 2s2, both subshells. That's why there is a minor drop, a small drop, even though there is an increased nuclear charge from beryllium to boron. That is the explanation. Do you get my point?
Yes, sir. Yes, sir.
Yes, sir.
কারো কোনো কোয়েশ্চেন থাকলে করো। The drop is minor. There is no dramatic drop kintu. So the increased nuclear charge will be offset or will be cancelled out by other two factors, which is 2p is higher energy level than 2s in boron. So the electron will be removed from 2p subshell of boron. So that is one added advantage why there is a small drop. Number 2, 2p electron will get shielding from 1s2 and 2s2, whereas 2s2 electron in beryllium will get shielding from only 1s2. So subshells or orbitals can also give shielding, that you need to understand, but the shielding will be minimal. But since the drop is minimal, we need to consider these factors as well. ঠিক আছে? এটাই দেখো এখানে ডিসকাস করছে। There is a slight decrease in first transition energy between beryllium and boron. Although boron has one more proton than beryllium, there is a slight decrease in first transition energy on removal of the outer electron. Beryllium has the electronic structure of 1s2 2s2, and this one is this. The fifth electron in boron must be in the 2p subshell, which is slightly further away from the nucleus than 2s subshell. There is a less attraction between the fifth electron in boron and the nucleus because these three factors we have already explained. The distance between the nucleus and the outer electron increasing slightly because of it is 2p1. The shielding by inner shells increases slightly because যেটা বলছি 2p will get shielding from 1s2 and 2s2, whereas this is boron and beryllium will get shielding from only 1s2. It's 2p1 will get shielding from 1s2 to 2s2, whereas 2s2, this electron will get shielding from only 2s2. Sorry, 1s2, only 1s2. So shielding, these two factors will outweigh the increased nuclear charge. Hopefully clear.
Yes, sir. Yes, sir.
Again, 3 marks. They will ask this question for 3 marks. So take good preparation. They can ask the same question for আচ্ছা এটা কেন মুছলাম না মুছতে ভালো হতো আচ্ছা এখানে দেখাই আমি they will ask the same question and your answer will be same for this এটা তো beryllium to boron আমি যদি ইয়েতে যাই সোডিয়াম magnesium aluminum silicon phosphorus sulfur sodium magnesium aluminum, then this is silicon, then phosphorus, sulfur, chlorine, argon. Do you understand? So there will be same pattern in period 2 as well. And they will ask you why there is a small drop between magnesium and aluminum. What's that?
Yes,
sir.
And why
Yes,
there is a small drop between phosphorus and sulfur? Same question will be asked. Similar. Magnesium to aluminum will have same explanation as beryllium to boron. Nitrogen and oxygen we didn't explain yet, but it's the same explanation. Phosphorus and sulfur. Same explanation. Let me explain magnesium to aluminum so you will easily understand. Magnesium, let me change the color of the marker. Red, brown, purple. Magnesium. You see, magnesium is 12. So what is the electronic configuration? 1s2, 2s2, 2p6, 3s2. Is it clear? Aluminum, 13. 1s2, 2s2, 2p6, 3s2, 3p1. In this case, we have explained 2s2 and 2p1. Here you have 3s2 and 3p1. So 3p1 is a bit higher energy level than 3s2. Number one. Number two, 3p1 electron will get shielding from 1s2, 2s2, 2p6, 3s2. All these subshells. Whereas this 3s2 will get shielding from 1s2, 2s2, 2p6 only. There will be added shielding from 3s2 in aluminum as well. So these two factors will outweigh the increased nuclear charge in aluminum. Here, same explanation.
Yes, sir. Yes, sir.
Okay, very good job. Very good job. So that is it. That is beryllium to boron and sodium to aluminum. Even though they didn't explain,
Yes, sir.
they asked, don't drop from the sky. It's the same thing. Okay, now we will try to explain nitrogen to oxygen or phosphorus to sulfur. Same thing. Achha. Yes. Let me explain nitrogen to oxygen, Phosphorus to sulfur is the same explanation. Nitrogen, again, 7. So it's 1s2, 2s2, and what? For nitrogen is 7. So 2p3, right? If we draw box notation, it will be 1s2, 2s2, and how will be the 2p3? 3 orbitals, singly filled, right?
Yes, sir.
Doubly filled nai kintu, singly filled. Tale oxygen 8. What is the electronic configuration? 2p4. If we draw the box notation, how is that? 2p4, first electron, second, 2p2, 2p3, 2p4, right? Right?
Yes, sir.
Yes, sir.
You see,
Yes,
the last electron of oxygen will be removed from an orbital which is doubly filled, whereas the last electron of nitrogen, we to dekhai konta last electron, nitrogen last electron হচ্ছে এইটা, এখান থেকে রিমুভ হবে, আর অক্সিজেনের লাস্ট ইলেকট্রন হচ্ছে এই যে একটা অ্যাডেড ইলেকট্রন ঢুকলো doubly filled orbitaler মধ্যে, that is the last electron. So what I am saying is the outer shell electron of nitrogen will be removed from a singly filled orbital. ঠিক আছে? So there is no spin pair repulsion. Electron repulsion নাই. But oxygen's outer electron will be removed from an orbital which is doubly filled, and that electron will face a spin pair repulsion. That is electron repulsion. এই যে ইলেকট্রনটা ওর ঘরে যে আরেকটা ইলেকট্রন আছে আগে থেকেই, ও ওকে রিপালস করবে. So it will get a repulsion force. So due to this spin pair repulsion, it will be easier to remove the electron of oxygen than in nitrogen, even though there is increased nuclear charge in oxygen. That will be outweighed. See, that is written here. There is a slight decrease in first transition energy between nitrogen and oxygen. Oxygen has one more proton than nitrogen, and the electron removed is in the same 2p subshell. Dekho, subshell the same. So you might think ionization energy would increase. However, the spin pairing of the electrons plays a part here. Spin pair repulsion boli etake amra. Unpaired, the electron removed from oxygen is contains a pair of electrons. The extra repulsion between the pair of electrons in the orbital results in less energy being needed to remove an electron. So the first transition energy is lower because of the. This is the key word here. Huh? This is the key word. So take this word. This is the key word: spin pair repulsion, or spin pair pairing repulsion. Huh? Electron repulsion. That is the thing. Do you understand? Number 4.
Yes, sir.
So again, 3 marks they will give for this.
Yes, sir.
They will give you 3 marks for this. And same explanation is for phosphorus to sulfur. You will get the spin pair repulsion again. So if they ask you this question, phosphorus to sulfur or nitrogen to oxygen, please draw the box diagram and explain. It will be easier to explain if you draw the box diagram. Talha, is it clear? Talha?
Yes, sir. It is clear, sir. Yes.
Okay. Rio?
Sir, Rio isn't here.
Rio is not here. Rio is where? And for Iader ki obostha? Tashnia?
Yes, sir. Understood.
ভালো করে পড়ো কিন্তু আমি কিন্তু
স্যার ভয় দেখাচ্ছেন কেন?
আমি কিন্তু কিছুই করতে পারবো না, বুঝছো? আর ডিটি ঠিক আছে, বুঝছো?
হ্যাঁ স্যার, বুঝতে পেরেছি।
ওকে, ঠিক আছে। লাস্ট ক্লাসের দেখছিলা, রেকর্ডিং দেখছিলা? তুমি কিন্তু লাস্ট ক্লাস মিস করছো।
হ্যাঁ স্যার।
ওকে, সো আমাদের অলমোস্ট শেষ। প্যাটার্নস ডাউন আ গ্রুপ. Patterns down a group is very easy. Lithium, sodium, potassium, rubidium. See, you see 519, 494, 418, and 403. So as you go down the group, the ionization energy is decreasing because of what? The distance between the nucleus and outer electron increases. So this is the main factor. The shielding by complete inner shell increases. So this is another main factor. Even though these 2 factors will outweigh the nuclear charge, because sodium is 3 protons, sodium has, lithium 3 protons, sodium 11 protons, potassium 19 protons, and I don't know rubidium how many protons, but definitely increased protons. So even though nuclear charge is increasing, other 2 factors, especially the distance between the nucleus and outer shell, and the shielding by the inner shells, the full inner shell will shield the outer shell. So these 2 factors will outweigh the increased nuclear charge, and thereby, as you go down the group for any group in your periodic table, the ionization energy will decrease. So they can ask this question for 2 marks. You will get in the past question paper, they're asking this question, 2 marks, and very easy. If they want to give you marks, they will ask this question. If you want them to struggle, then they will ask you number 4 point. Why there is a discrepancy between nitrogen and oxygen. If they want you to struggle more, then they will ask you why phosphorus to sulfur there is a decrease. Okay? So be aware. So that is it. Done. Done. Summary. You will see the summary. And exam style questions will start. We need to complete them. Okay, let us come back and let us discuss few points regarding exam style questions. Come back.